Hello and welcome to another one of D's ADD videos. Today we're going to be looking at a special case of relative extrema in which the critical point comes from the continuous yet not differentiable scenario. So what do I mean by that? That sounded like a bunch of gibberish probably to a lot of people. I mean, when you take the derivative, in this case I would need to rewrite it first, right? X squared minus 9 to the 1/2 power. You bring down the exponent, you rewrite your expression, subtract 1 from the exponent, and then multiply by the derivative of the inside. You should be able to see that the 2 cancels out, or you could have canceled out with that 4 either way, and you're left with 4x on top. And that negative exponent tells you to bring down. Your base. And there's your first derivative. So you should be able to look at this and tell me that there's 2 points that were defined in your original function up here that are no longer defined in your derivative. In other words, it was continuous but not differentiable. That's what that means. Another way of saying that is f prime of number is undefined, where f of number is okay. It is defined. Undefined. Alright, so in this case, if I set the denominator equal to 0, actually let's do the one you're accustomed to should be the 4x equals to 0. The red is me finding my critical points, my critical numbers. So x equals 0 is 1. And then the other one comes from the fact that if I set, I don't need to worry about the square root. If it was there and I set it equal to 0, I square both sides. 0 squared is still 0. Or no matter what power it was, it would have gone away. By the same logic, then you would factor, and you get x cannot equal plus or minus 3 in the derivative. So that means therefore you could say x equal plus or minus 3 are critical points because they were continuous at values. Actually, let's just say at x equals 3 and negative 3. But not differentiable. And you would need a little explanation like that. So then when you did your number line, you would need to plot negative 3, 0, and positive 3. These are our possible maxes and mins. And now we can plug in a number to the left and the right of each of those our test points. So I'm going to use first a negative 4, then a negative 1, positive 1, and a positive 4. So I want to plug into the first derivative. Actually, you could simplify your work quite a bit by looking for the domain to begin with. And we know that x squared minus 9 has to be greater than or equal to 0. We do sign analysis there, and I get negative 3 and 3. If I plug in a 4, I get positive. Plug in a 0, I get negative. positive. So your domain is everything here and here. I don't even need to plug in anything in between. And also that tells me 0 is not even a critical point. Okay, so all that region actually is outside our domain. Alright, so if I plug in -4, that means that I have a, where's my first derivative? -4 times 4 is negative, and then this answer is positive, so therefore it would be a negative or decreasing slope. And then if I plugged in a +4, that would be positive and increasing. Now we don't have any relative extreme in this problem because there's no other side to have the increasing or decreasing the other half of it. So we can state that it was increasing from 3 to infinity and decreasing from -infinity to -3, and there are no relative extrema. Alright, so practice, practice, practice. It's a key to improving your skills in these. Eventually we'll do second derivative test and then put it all together and do some curve sketching. So if you're having troubles now, it's going to be a lot more difficult when there's 3 or 4 more additional steps, including graphing. Thank you, and have a nice day.